All right. So today I was trying actually to create the Databricks account, but for some reason it failed. So it could happen. I hope you guys also were able to create your free trial account like we have practiced yesterday. Sometime it can fail also, and it can have some issues. So I show you here. For example, I try to create an account here and it was in failed state. But now it looked like it has recovered, but I'm not sure about the resources which are created here. Let me see. Three resources. I think one resource is missing. Some component is not being created, but we can try. So in the resource group, NICIT, I created one Databricks service. And when I go here, it is like failed. So the deployment was not complete on the Azure basically. So you can face this issue as well sometimes on depending on the reason, your account and all those things. So it could have, failure as well. Anyways, so we cannot use this workspace because it will not work anyways. So in that case, we simply have to go to a resource group and delete the resource group. It will delete all the dependencies and this Databricks workspace. So you just need to select your resource group, put it here and hit on delete, and it should clean it up. Maybe I will have to use another Azure account because on my Azure account, it was a failure of the deployment. So maybe you can see here in the deployment history, I believe it will show us the history of failures. Mm, deployment, yeah, deployments. So it will show the history here. However, it is showing actual deployment successful. Today is 22. Let's refresh it. Yeah, let's see the last one. We can see the deployment history here. So it was talking about the resource group, not the resources. So you see that last deployment was about the resource group and all those things, but not about the resource. So, it can happen that it will not work sometimes. So let me see. You can even redeploy or try attempting new deployment as well. So that's fully possible. Okay, so we are removing our deployment from here, but I have sometime created one account in community edition. So you can also try. This is totally free, but it will have the limited options available. So you can use your private email address and create your own Databricks account on the community edition. So let me see, is your or you can simply call Databricks Community Edition. And you can sign in for this and it will not charge you anything. Databricks, I think here somewhere we can find the detail also, but it is not for commercial use, so it is free of cost. It's totally free actually. Okay, so community edition, you can sign up and there is documentation also available from Databricks. Okay, and you can use with which you will be using, maybe Azure, AWS, GCP, and all those you can select. and it will have the basic, login and all those things. All right, so today we'll talk about something on the theoretical part. The reason is our Databricks account is not ready, so tomorrow I will keep it ready with the Azure, so it will should be working. All right, so today's concept we will cover is Apache Spark. So we'll understand about this concept with the Databricks, how it works, and what are the features we can use. So question is, what is Apache Spark? So Apache Spark is a distributed processing system that help you to analyze large amount of data. Okay, and just give me a moment. I will just set up my screen. Okay, so it's a distributed processing system. So distributed means it can distribute the workload. Okay, and to analyze your large amount of data, like big data, you can call. It's a fast open source engine that's used for machine learning, AI, and big data applications. Okay, now let's see the feature of Apache Spark. It have the capability of processing in memory. Means it doesn't require, a disk basically. So it will not be processing the data on the disk. If it is processing like Hadoop is processing in the disk, So it does use the storage actually to process the data. But in Apache Spark, the advantage why people move to Apache Spark is it process the data on in memory. The Spark keeps the data in memory for faster processing speeds, because if it is processing on the disk, it is going to take, input output limitation is there. So in Mbps it will go, but in memory it is quite fast. Then the second feature in Apache Spark is built-in modules. So it has some built-in modules which are really helpful. So Spark has modules for SQL, streaming, ML, and graph processing. So these modules are helpful to process the data. Then next advantage here or the feature is that the programming languages, Spark has native buildings for Java, Scala, Python, and R. Okay. Next is code reuse. So you can, it supports code reuse across multiple workloads. Scalability point of view, Spark is designed to scale for big data. And the flexibility, Spark is more flexible than Hadoop, which is primarily used for disk-heavy operations. Because if we have disk-heavy operations, we can, use the in-memory processing, and that is really making it fast. Okay. Now, what is the PySpark? Because when we learn about Spark or hear about the Spark, the next topic comes is what is the PySpark. So PySpark, like this symbol denotes here, the combination of Python. So this is the Python logo and this is the Spark. If we combine them together, it becomes PySpark. So PySpark is a Python API for Apache Spark that allows user to perform data processing and analytics using Python. Okay, so the Apache Spark is written in Scala programming language. PySpark has been released in October in order to support the collaboration of Apache Spark and Python. Okay, so this is like you can call APIs, Python APIs, which are being used with the Apache Spark. Okay, in addition, PySpark helps you interface with the resilient distributed dataset RDDs. Okay, and RDD in Spark and Python programming language. So this is one of use here. This has been achieved by taking advantage of py4j library. So they have created one library which will be helping to, combine these both the features together. And py4j is popular library which is integrated with PySpark and allows Python to dynamically interface with the JVM objects. Okay. And what is the resilient distributed dataset? RDD is the fundamental data structure in Apache Spark. Okay. So this is you can see it is a data structure which is being used in the Apache Spark that allows for parallel processing. And it, RDD helps us to process the data in parallel of data distributed across multiple nodes. So like when we call multiple nodes is talking about cluster, CULSTER. Okay, cluster, and RDD are fault tolerant and can recover from bugs and data loss. So this is the one of advantage of this data structure used by Apache Spark. Okay, then the features of PySpark. So PySpark supports many of Apache Spark features, including uh, MLlib and data frames and Spark SQL. So these are the features which are supported by PySpark. In data processing, PySpark can perform real-time, large-scale data processing in distributed environment. Okay. And the next is data types. PySpark supports a variety of data formats, different sources, different format, including Python, R, Scala, and Java. So data structure, if we talk about data structure, PySpark uses data structure called data frame, which organizes data into two-dimensional format similar to a spreadsheet, like columns and rows. So it manages the data or organize data in a spreadsheet format. All right, so next is libraries. So we have understood that it uses this library, py4j library, allows the Python to interact with the JVM objects. Ease of use, if you see, PySpark combines the performance of Apache Spark because it's in-memory processing with the ease of using Python. Okay, applications. PySpark is used in many data engineering, data science, and ML applications. So these are the features or the uses of PySpark. Now let's understand what is the Databricks. So a Databricks is a unified open analytics platform for building, deploying, and sharing and maintaining enterprise-grade data. Okay. Then analytics and AI solutions. So it is used to manage or deploy enterprise-grade data, analytics, and AI solutions. The Databricks data intelligence platform integrates with the cloud storage and security in your cloud account. So regardless of your cloud account means you can work with the your cloud storage. If you are working with the Azure, you will be using the storage service. If you are working with the AWS, I think S3 you will be using. So like whatever the storage service available in your cloud platform, you can use with the Databricks. And security also is used with your cloud account and manage and deploy cloud infrastructure on your behalf. So basically it will be taken care by Databricks or it will be used by Databricks on your cloud account. So it will authorize the Databricks by tokens, and Databricks will be managing your storage and compute power from your cloud account. So what is Databricks used for? Databricks provide tools that help you connect with your sources of data to one platform to process, store, share, analyze, model, and monetize your data sets with solutions from business intelligence to generative AI. Okay, these are like core uses of Databricks, why we are using Databricks or why industry is using The Databricks. The Databricks workspace provide a unified interface and tools for most data tasks, including data processing, scheduling, and management, in particularly like ETL process, generating dashboards and visualization. We can generate dashboards out of these notebooks, which we'll be using. And we can also create visualization from the queries which we are using in the notebook. Okay. And next is managing security, governance, high availability, and disaster recovery. So here, these are some of the tools or features. And then we can use data discovery, annotation, and exploration for that purpose. Then machine learning, modeling, tracking, and model serving, and generative AI solutions. So these are some of the common use for Databricks. Now let's understand the Databricks high-level architecture. Okay. So basically, Databricks is like prepared with the two planes, which is one is the control plane. Most of the like data analytics solutions have this architecture, so it's like pretty common. Like control plane is like control plane includes the backend services that Azure Databricks manage in your Azure Databricks account, the web application in the control plane, and the compute plane is where the actual data processing is happening. So compute plane is where your data is processed. There are two type of compute planes depending on compute that you are using. So first is serverless compute. The serverless compute resources run in serverless compute plane in your Azure Databricks. For classic Azure Databricks compute, the compute resource are in your Azure subscription. So like serverless compute is basically not running on the Azure one, but rather in the Azure Databricks, plane, like workspace we are creating. This is running where there. But when we are talking about the classic one is basically you are creating a virtual computer in your Azure subscription. Okay. What is called classic compute plane, and this refers to the network in your Azure subscription and its resources. Okay. Now, if we understand about high-level architecture of Databricks here in this diagram, we can understand this like how the workspace system data, Databricks file system, and Unity catalog workspace work together. So here you can see in this diagram that when you create a Databricks account along with your cloud or Azure in our case, so how it is organized. So you can see your compute power is being provided from your Azure account. So the classic compute power, and your storage account is also created on the Azure. So this is like your cloud provider, either Azure or AWS or whatever else. So these resources are created on your cloud environment. And on your Databricks account, actually, you have control plane where it will be managing your Databricks web application. It will perform the compute orchestration. It will manage the permission using the Unity catalog. Unity catalog is like it's like taking the control of your cloud account and managing the permission for you. Queries and code will be performed here on the Databricks account. So these are like these are the stuff which is happening on the control plane. And when you're talking about serverless compute plane, means the compute which is happening on without actual the virtual servers. So it's like service which is again happening on your Databricks. So this red dotted box represent that whatever happening on your Databricks account, and the blue one or the purple one is basically your cloud account. Okay. And your data resources like your databases or your on-premise data which is available maybe on the cloud or physical one will be dealing with your Databricks account. Then definitely the authentication and this thing in especially in Azure or Microsoft environment is taken care by Entra ID. So this is like on high level, you can understand the Databricks architecture. Next thing is about the control plane. If we see what are the, we have in database subscription. So Databricks cluster manager, basically a role or a service which is dealing with the Azure resource manager. So this part represent Azure, and this part is like Databricks. Okay. So here, if you see, we have Databricks user interface. We have Databricks cluster manager, which is the in charge of managing or creating, spinning off the virtual machines and all those things. With the help of definitely Azure Resource Manager. Azure Resource Manager is like core component which takes care of deployment of resources, and that will be instructing the Azure to create or remove the virtual machines from the cluster. Then we have a Databricks file system in Databricks control plane, which is the file system which is now about to deprecate, and I think it is deprecated and still it's being used, available in Databricks, but in future it will be deprecated. So Databricks file system is used to manage and it is having some Python libraries with this, which we will be using with the notebooks. And then definitely the cluster, which is being used with the Azure. Now, next is Azure Active Directory, which is used to authenticate. So it is like the previous one, it is the same diagram, but having like components in it. So in data plane, if you see in the customer subscription with Azure, what we are getting? We are getting Databricks workspace created, as we have seen that when we create a Databricks in Azure, it show us the workspace created there. But actually, it is working on this control plane. But this is like the representation here in the Azure, and we will be using Azure blob storage for storing the information which is being used by the Databricks. So permissions of the blob storage, virtual machines, workspace is taken care by Databricks basically. Next, in the cluster, so when we create the compute resource on the Azure or even AWS or any cloud platform, we have basically cluster modes available. So we can have single node cluster or multiple node cluster, and it can have access modes depending on the use. So it can be used for single user, shared, or no isolation shared. So a single or multi-node cluster is basically a multi-node cluster have one driver node. So when we talk about the cluster, we have one driver node, or you can call it like master node, and one more worker nodes. We can combine this role to one compute as well. Okay, so I think that is called the single node. They provide the ability to horizontally scale the cluster depending on your workload. Okay, these are the default type of clusters used for Spark job and are suitable for large workloads. So this automatically takes care of cluster expansion or scaling, and it can horizontally scale, means it will keep adding the nodes. So virtual machine 1 is running, and if there is more workload, then it will add another virtual machine. If there is one more requirement, so it will this is called horizontal scaling. Okay. Now single node clusters have only one node basically, which is the driver node, and has no worker node. So basically it is playing both the roles here. When you run a job, the driver node act as both driver and worker node. Okay. Is there are no worker nodes, single node clusters are not horizontally scalable. Basically, it is limited to one virtual machine and it cannot be, expanded or have multiple virtual machines. Okay, now we talk about access mode. So how many access modes are available? Let's see. Single user means single user access mode permits only one user to access. Okay, so when we create notebooks, we have notebooks and we have access to that notebook, and it will be accessed by the one user who will create the notebook basically. Okay, the cluster and the cluster and supports for languages, so Python, SQL, Scala and R is supported, and the notebook we will see as well. In the shared access mode, we have shared access, or it will allow multiple users to access the same notebook. So when we create the notebook, if it is shared one, multiple users can work on that notebook or access that notebook, run that notebook, etc. It is only available in premium workspace and supports Python and SQL. Okay, so shared one will support Python and SQL. No isolation shared. Shared access with no isolation allows more than one user to access and collaborate. So this is a little bit advanced. The multiple users can work together on the same notebook. Okay, it is available in both standard and premium workspaces. Okay, supporting 4 languages. It supports Python, SQL, Scala, and R. And here, if you see for shared one, it support Python and SQL only. So these are like limitation here. So you have to keep in mind. The key distinction between the shared access and no isolation is that it doesn't provide process isolation. Okay. So this is only the difference we have between shared and no isolation. Okay. Now let's talk about Databricks runtime. So let's understand what is the Databricks runtime here. Databricks runtime is integrated and optimized runtime environment provided by Databricks. Okay, it includes Delta Lake. There is we will talk about this concept in coming video slides. So we have something called Delta Lake, pre-installed Java, and we have Scala, Python, R libraries, GPU support. So these are like called Databricks runtime, and which is integrated and optimized runtime environment basically. Okay, so it is provided by Databricks, and Delta Lake is like big concept. When we talk about Delta Lake, we will be talking about data lake house. This is one concept, lake house. Okay, so this is relatively new concept in the Databricks. We'll talk about this. Let's understand in the cluster point of view, when we are creating the compute power, what are the feature available in that. So we can see first one is auto termination. So when we are creating the cluster or cluster resource, when we are using, it has auto termination feature available. So I'll quickly show you as well. I think if I have here. So when we go to compute, here we should have somewhere. Let me see if I can edit it. So this is my free account basically, and it should also have auto termination feature somewhere. So basically, it will automatically turning off. So right now it is not running because it is terminated. So when I run, and after 10 minutes, if I'm not using it, it will be automatically turning off. So this is like when we are using this feature, it will automatically turn off your computer. So virtual machine or virtual resource will not cost you basically. So this is what the auto feature is here. I'll simply, okay. So this is what the auto termination here. Auto termination is useful feature That helps avoid unnecessary cost, because when your compute resource is the running without use, it is even costing on the Azure platform. It automatically terminates the cluster after X minute, let's say 10 to 1000 minute or something you can define. With the default value of 120 minutes, the auto termination range is starting from 10 minutes minimum to 1000 minutes. Auto scaling. So auto scaling in Azure Databricks automatically adjusts the number of workers and disk space to meet uh, the needs of your workload. So as you have like more and more processing requirement, when you are, let's say, running some data of terabytes or petabytes, then maybe it will automatically be increasing the number of virtual machines which will be performing or working parallel to, cater that demand. Databricks runtime versioning. So Databricks releases runtime version regularly, encompasses the long-term support LTS feature and major version. So it keep updating, and when we choose the runtime, it show us with the LTS. So this is the runtime updates or versions from Databricks. Databricks unit, or what is this is what the concept when we are being charged on Databricks. So Databricks unit is DBU. It is called DBU is a unit of measurement for processing power on Databricks Lakehouse platform. So this is like processing power on the Lakehouse platform, which we will understand in coming slides. So the Lakehouse basically provides us the ETL process. Okay, so the whatever processing is being consumed here by the Lakehouse is charged in DBUs. It's used to calculate total amount of compute resource such as CPU, memory, and input output used to run the workload on Databricks. So basically, the Databricks platform will charge us on the DBUs, and this is like unit. I think we have seen it yesterday as well on the calculator, I believe. Let me see. Azure, or I will say Databricks calculator. DBUs, I believe. Yeah, Azure Databricks pricing. On this, you will see like we have compute power. We can select from drop down, and still it is loading in the background, looks like. Yeah. Okay. So here you can see with the premium tier, still drop down is not working. And pricing, it is going to show in per hour basis. And these are like features available, which we have seen yesterday as well. And these are DBUs per hour. So like $0.4 DBU per hour. Okay. So like premium tier, we have different DBUs for different job compute or compute power. So commonly used is all-purpose compute, which is around 0.4 to $0.55 per hour. Okay. And this is on pay as you go account, means when you have basically when you create the Azure account, you will start with the free trial, and then you will have to update it to pay as you go. And these are the reviews for different purpose. But if you reserve your instance for 1 year or something, you will get some Databricks commit units, and the prices are here. So $12,000 around 4% discount you will get on this. So this is like commitment from the organization, like 3 year commitment, pre-purchase plan. So these are like huge amount here. Okay. So let's go back. I'll minimize this. So when we talk about DBUs, DBU is a unit of measurement for processing power on Databricks Lakehouse platform. It's used to calculate the total amount of compute resources such as CPU, memory, and I/O used to run the workload. Now let's see what are the policy on the cluster. So when we create the cluster, what are the policies here and what are the type of cluster or size of cluster available. So we have like memory optimized cluster available, compute optimized custom cluster, storage optimized, general purpose, and GPU accelerated. So generally we use the general purpose cluster types. So these are like for common use when we run the notebooks or experiment with something. But let's say if we have, huge demand of memory one, then we can go for this one. But this will be happening on your actually, organization's account only, where let's say they have large amount of data set where they want to, process in memory, then the memory optimize or compute optimize. If this is living, let's say having a lot of computational power needed, then maybe you can go for this storage or GPU related also you can go. As long as cluster policy is, concerned or having, policy related to cluster is the first one is unrestricted means compute is scalable and the flexible compute option that allows you to provision and manage clusters without any predefined limits. Okay, so this is like one cluster policy where if you are not having huge amount of data and it's not going to overrun with your cost, then maybe you can use this where you don't have any predefined limits. But there is another one cluster policy which is the like personal compute, which is the default policy in Azure Databricks that allow users to create single machine basically compute resources with their own use. So this is for individual use only. Power use compute also available, which is power user compute policy in Azure Databricks allow user to create large multi-node resources for single user workloads. So user is single, but the compute is available in multi-node. Okay, so this is called power user compute. Okay, that require more compute resource than the personal compute. So this is like upgradation of this one. Then shared compute. So Azure Databricks shared compute is a cost-effective option for running Databricks workloads. It provides a pool of shared resources that can be used by multiple user or application. So shared compute is where you have multi-user environment and this the same compute power. Maybe let's say if we have this cluster of two computers or compute power, and let's say we have three users, so let's say if this user is using this compute power, and this user can use the same compute power, and so it can be scheduled separately. So they can use the same compute power, means each of the user can make run their queries and all those things, but it is managing it is being used by these all people or scheduled different times or something like this. So shared resources you can see. Next is Databricks workspace. So now we are talking about the workspace of Databricks. What are the component of Databricks? So the workspace is an environment basically for accessing all your Databricks assets. It organizes objects like notebook, libraries, dashboards, experiments into folders and provide access to data objects and computational resources. So this is called the workspace, which having notebook, folder, library, and ML flow. So what is the notebook? Notebook is a web-based interface to documents that contain runnable commands. So notebook is nothing but a document where you can write your commands and run your commands. So you can write your command and run your commands. You can visualize your charts, or it can prepare based on the result on the commands. You can view the charts and you can write like narrative text and all those things. So this is the use of notebook. Then what is in the folder? It's used to maintain grouping and hierarchy. So we can create folder and organize our notebooks or data and all those things. Then next is the library, a package of code available to the notebook or job running on your cluster. So if either we are running a job or we are running a notebook, it might require some library. It's like, plugin sort of thing where you can use the libraries along with your notebook. Databricks runtime include many libraries and you can add your own as well. So these libraries will work with your notebook. Then next object is ML flow, and ML flow is the collection of ML flow runs for training a machine learning model. Okay, so this is called ML flow here. Next is Azure Databricks Workspace Assets. So we have understood or largely talked about clusters, what we have in the cluster. So it will provide the unified platform, various use cases like running the production ETL pipeline, streaming analytics, ad hoc analytics, machine learning. A cluster is type of Databricks compute resource. So we have gone through this. Notebook also we have understood. Notebook is web-based interface to documents containing a series of runnable cells. There are, multiple commands you can run on one notebook that operates on files and tables, visualizations and narrative text. Also, commands can be run in sequence one by one, referring to the output of one or more previously run commands. So you have cells basically in notebook. So let's say if we are running one command here, then the result is we are using here, and we are running the second command, then we are using the third cell, and so it's like cell by cell, and we can run command by command. Now, next concept is jobs. Jobs are one mechanism for running code in Databricks. The other mechanism is notebook. So basically, job is like you can schedule the job, you can combine the multiple, notebooks in the job and run together. And then the libraries we have talked about. So this is like third-party libraries, locally built-in code available to use by notebook basically. And you can use this with your notebook and cluster. So this is called libraries. And then next is the data. Data, you can import data into distributed file system mounted into Databricks workspace and work with it in Databricks notebooks. Okay. So let's say if we are, uploading a CSV file or any data we are bringing into uh, the data plane of or Databricks workspace, we can use along with the notebook and cluster and process this data. You can also use a wide variety of Apache Spark data sources to access the data. So either we can use, Apache Spark data sources, or we can upload the data into DBFS, for example, and we can use this. Next is files. In Databricks runtime 11.3 LTS long-term support and above, you can create and use arbitrary files in Databricks workspace. Files can be any type of file, like common example, like py file, md file, csv file, txt file, log files. So these sort of files you can create in Databricks, and which will be called files in the Databricks workspace. Next is next type of asset basically in the Databricks is like Git folders. You can also have Git folders and Gits. You can use the code here. So Git folders, Databricks folder, those content are co-versioned together by syncing them to a remote Git repository. Okay. And using Databricks Git folders, you can develop notebooks in Databricks and use a remote Git repository for collaboration and version control. So basically, the idea is like if multiple developers working together, they can use the Git repository as a distributed version control system. and they can, develop the code and upload to the remote Git repository and share it with each other. Okay. And they can collaborate, maybe they can change the code, they can maintain the version history of their code or notebooks and all those things. Next is models. So model refers to model registered in ML flow, model registry basically. So this is, they call ML flow model registry model. Model registry is a centralized model store that enables you to manage the full life cycle of ML flow models. It provides chronological model lineage and model versioning, stage transitions, and model version annotations and descriptions. So we'll talk about this when we go to ML. So we are talking about Git folder, models, experiment, queries, dashboard, and alerts. These are some of the component in the Databricks workspace. So as we progresses with the this course, we will be going through this and talking in more detail. So we'll look into it, like queries are SQL statements, dashboards. We can create the visualizations combined in the dashboard. Also, we can have alerts and notification with the query and thresholds. Okay, and next is Databricks file system, or this is anyways going to be deprecated in future, but it is still being used. So we'll talk about this in briefly. Let me just see. All right, so should have pen tool. Okay, Databricks file system, or DBFS, is the distributed file system mounted into Databricks or Azure Databricks workspace and available on Azure Databricks clusters. DBFS is an abstraction on top of scalable object storage. So basically, it's like database or what you call Databricks file system, which works with the your data. So it's like, it is like a file system which is working with your meta store, and it's like middleman in the between of this both. And when we have the DBFS we use, we can use the location where we can keep our data file and data sets and the results which we are generating using on this. So we'll go through this on the notebook and it will make more sense. So here we'll talk about this. These are some Databricks utilities which we can use with the DBFS. And these are utilities which are, basically the Python utilities. And this is where, that's why when we started this course, we said we don't have to learn entire Python. We just need to learn the DB utilities or utilities being used by the Python. And that will help us to understand the, the process, entire process. All right, so most of this thing we have already covered here. So the core concept, I think we have covered in the slides. Now, one concept which is left is a data lake house. So let's talk about what is the data lake house. Okay. So we have heard like data warehouse. Maybe this term is very common. You guys are from the data background, so you can understand data warehouse, and probably you may have heard the data lakes as well. But this is something new, the lake house. Basically, this term is created using these both together. So the combination of these both is basically the lake house, or data lake house. All right, so let's go here and understand the data warehouse. Data warehouse, basically, we have data available and we can use this data for ETL process, and it lands into data warehouse. And from this data warehouse, we can create some outputs. And what are the pros of using data warehouse? That we can use it in the BI analytics, and the data is structured and clean data. Basically, this is structured, like we in the, I think, first session we talked about structured structured and unstructured, and also semi-structured, I think. Okay, so these three type of data we discuss about. So data is structured means it is arranged in rows and columns. So it's easy to analyze. And here structured data is clean basically because it is having the acid properties where you have integrity and all those things. And it is having a predefined schema. So in this case, we can use data warehouse, and data warehouse can easily produce the result. What are the negative points of data warehouse? What are the cons? There is no support for semi or unstructured data. So we cannot deal with the data which is not structured in this case. So data warehouse case, we are not able to produce anything meaningful out of this or ETL process if we are having a data which is unstructured or semi-structured. This is useful when we have the structured data only. Inflexible schemas. So if we are dealing with the inflexible schemas, we cannot work with this process of data warehouse, and we can struggle with the volume and velocity upticks. So when we have large amount of data, this process really gets very slow to analyze, and it does take a lot of time to perform. Long processing time compared to other processes. So this is time consuming to analyze the data. Okay. Next is data lake. So we covered data warehouse. Now next concept is data lake. Data lake is flexible data storage basically, and it supports the streaming data as well. It is efficient basically in the cloud. So you can simply create a storage account. So when we talk about Azure storage account, or maybe S3 in AWS, so we can use them as a data lake. Okay, and we can use to store, let's say, structured, semi-structured, or unstructured data. It could be audio files, videos, pictures, or anything. So binaries, we can use all this kind of data with the data lake. It supports for AI and ML as well. So the same data we can use it for AI and ML. Now, what are the cons here? There is no transactional support. So these data are unstructured, so we cannot have the support of transactions, or we cannot have ACID properties here. And then poor data reliability. We cannot have, reliable because there is no fixed schema with them. And slow analysis performance and data governance concerns. So managing the security or accessibility of data is difficult. Data warehouses is still needed. So for structured data or the data which is having the schema for ETL process, we require data warehouses. Even we do have data lakes, but if we are processing structured and unstructured data, then we require data warehouses. Okay, so what are the challenges here? The challenge is like complex technology stack. So a combination of data lakes and warehouses. We have, work with the both. We have, so one end for, unstructured and semi-structured data, we will be using data lakes. For structured, we will be using data warehouses. And then both the data we cannot combine. So these are working in silos. There is high cost and complexity because two different solutions we will be going with. And then the emergence of data lake houses. So this is to meet this challenge, the data lake house is introduced basically. Okay, because we were having these challenges, because we were using data warehouses, we were using data lakes for unstructured and semi-structured. We were using the warehouses for structured one. So to meet this complexity or challenges, they introduced something called lake house, and it combines the benefit of lakes or data lakes and warehouses together. And it supports the diverse data types and workloads, means it supports all kind of data, which is structured, semi-structured, and uh, unstructured. Features like transaction support and governance also here. So let's see. The business required two disparate, incompatible data platforms. So this was the challenge when we were using data lake. So data lake was being used separately, and data warehouse is used separately. And these both or two solutions are going in parallel. Okay. And these are disjoint. So these are not connected, having different silos. And here this data is used for data streaming and data science and ML purpose. And the data with having table structure, access control list, and all those things are used with the SQL analytics and business intelligence. So these are like disconnected model. Okay. Now the solution is data lake house. This is what they come up with. Okay. So with the basically Databricks, we are using data lake house. Okay. Let me just, okay. So data lakehouse is a data management system that combines the benefit of data lake and data warehouse. So this is what the advantage here we have. A data lakehouse provides scalable storage and processing capabilities for modern organizations that want to avoid isolated systems. So basically, we are combining these both the system data lake and data warehouse together in data lakehouse. System for processing different workloads, so we can process any of this workload, maybe the structured, non-structured, semi-structured, and also it can be used with the ML, BI, and these processes. Data lakehouse can help establish single source of truth, eliminate a redundant cost because it's combined both the solution in one, and ensure data is fresh or freshness of data. Now, if we talk about data lakehouse, often use data design patterns, incrementally improves, enriches, and refine data as move through the layers of staging and transformation. So from here, we'll talk maybe in detail, or this is like, Databricks solution in terms of data, how it is performed. So we may have different data sources, maybe structured pictures or semi-structured codes, binaries, any kind of object. By default, it will be changing it to data table, and data table can further be transformed to another type of data tables. And then finally, it will be useful for the results, and we can produce some outputs from that. Okay, so this is like, and the Unity catalog basically is like governance. So it will take care of your security stuff here. Okay, so Unity catalog is going to take care of security, and this is how the data is being, transformed, and multiple data sources being used. So this is like simple diagram. And this is the diagram for data lakehouse, okay, where you combine the data warehouse and data lakehouse together, and you reach to this scenario here, which is called Delta Lake. Okay, so basically, if you see in this diagram here, you can see that your data warehouse and your, what do you call, unstructured data or data lake is combined in Delta Lake, basically. So this is like additional layer which you are preparing between data, and then you can perform your ETL process. You can combine all of your outputs together and make some insights. So this is what we are doing here with the help of Delta Lake. And Delta Lake you assume is a additional layer in Lakehouse system. Okay, so Lakehouse is the combination of warehouse plus Data Lake. All right, so that's it for today. Bye bye. Take care.